All right, hello everyone. My name is Justin Nguyen, and I'm the president of Robotics at U of H. And I'm going to get started. All right.
You're live.
Yeah. See here. Next, right? Yeah. Wait, are you controlling the slides?
You're controlling.
Oh yeah. Go ahead. All right. So robotics at U of H. Who are we? So we are a group of robotics enthusiasts. So we like to. All right. Hello everyone. My name is Justin Nguyen, and I'm the president of Robotics at U of H.
Oh crap!
And I'm going to get started.
Shiz. Right, because I still have this open.
Okay. All right. So who are we? So we are a group of robotic enthusiasts. So we like to play with robots, talk about robots, and even build some robots. All right.
I moved this around, so I don't remember exactly which way I'm supposed to go.
All right. So a brief history about us. So we started back in 2019 as named UH Drone Racing. So that was way too specific, right? We like to play with we like drones, but like not like everybody likes to play drones. So in starting 21, we rebranded ourselves as Robotics at U of H, and we are a group of students who came from different engineering orgs, including IEEE, ASME, AIAA, and other orgs as well. So we are a group of more casual engineer groups. So other orgs, they like to be focus on more the professional side, and we're just more casual. We like to actually get to play with robots. Oh, all right. So here with me are my fellow officers. So we have Aaron, the vice president. We have Ashiana or David as our secretary. Charles is our treasurer. He's unable to be here today because he was sick, unfortunately. But we do have Ida here, our outreach coordinator, and Ethan, one of our combat robotics chief, and also Aiden, who is also making his way here as well. So Ethan, would you like to tell the group more about BattleBots, our main event?
Yeah.
All right.
So BattleBots, it's based on the show. Don't know if many of you've seen it, but it got pretty popular. So we make robots with ranging weight classes that basically fight each other until one has till the time ends or one cannot move anymore. It's mainly so the weight classes are we start with 150 grams and then 1 pounders. Then it goes on to 3 pounders and beyond, but we're mainly focusing on 150 grams and 1 pound bots. So what happens is the BattleBots are.
They're inside a ring, inside like a box, a ring?
They're inside a cage to basically protect you and keep the bots in one space. Points are awarded based off of control, aggression, and
control, aggression,
and damage. And after 3 minutes, or until one of the bots is unable to move or loses control, points will determine the winner, or the one who loses control or cannot move loses.
You're done, right?
Yeah.
All right, next. Yeah. All right, so let's see here. So starting with like our first ever year here. So our team building progress. We started with like roughly 3 weeks to build a bot, and then as Ethan mentioned, our first bot had to weigh like under 150 grams. And budget, we would like to have more because BattleBots are super fun, but they're also very expensive. But see next. And these are some of our pictures from the competitions that we competed in. So we competed at the Ion here in Houston. Additionally, we also competed up in Texas A&M, and our recent competition was at Comicpalooza. All right. And this is one of our clips back at Texas A&M. Our team member is representing U of H is the robot in the block. Oh, let's see here.
Gosh darn it.
All right, so we are also going. This semester, we're also going to be bringing in like casual, beginner-friendly drones that we can allow students to mess around with them and then potentially become interested and become a professional pilot. I'm going to let Ethan, sorry, not Ethan, David, our drone enthusiast, to talk a little more about that.
Hello, I'm the secretary and I had a huge interest in drones. That's why I joined before they got too expensive. So I don't really touch upon them anymore, but if you are interested, I recommend looking into the 107 exam, because if you get certified and take that exam, you can make money off of drones if you're professional enough. But if you're just a casual flyer or you want to do recreational flying, you can take something called the trust test, and I'll put more information on that in Discord, and if you have any questions, you can DM me.
All right, and so as so just go back a little bit. And so as a reference, I've talked to a bunch of professional pilots, and they said that of course the exam's like it's expensive, but it's like roughly $150, so it's not going to like break the bank. And they said that they can make at least $500 per hour per drone, just doing like simple stuff. But like it's not just also photography, professional photography. It's also stuff like inspection as well, because like if you're hiring a like professional, it'll take a lot of time, a lot of money. Whereas if you just like use a drone, it's a lot more a lot cheaper, and like saves a lot of time as well. All right, next. All right, and see for our upcoming events. So our main event right now is our tournament that we're going to be hosting at U of H is going to be on October 28th. Additionally, we're going to be competing in a BattleBots tournament every month. The first one that's going to be happening in a couple of weeks is the September Scuffle, which is going to be happening at the Electronics Part Outlet, EPO. It's here in Houston. And the Turkey Tussle happening on November 18th. It is free to attend. It's only you only have to pay if you're competing. I believe it is $10 for the 150 gram class, and then $20 for the 1 pound and 3 pound class. Additionally, we have been having a lot of collabs with IEEE, and so our upcoming workshops are going to be talking about Fusion 360, the CAD software that we use to CAD our BattleBots with. Additionally, the software that lots of hobbyists use as well to CAD their own BattleBots or other hobbies as well. We'll also be having a 3D printing workshop, because you can't have BattleBot, you can't even 3D print it in the first place. Alright, so if anybody is interested in joining, here is the QR code to fill out our membership form and to join our Discord server. Alright, let's see, yeah, give me like 2 minutes. And let's see here, if you guys didn't get all the information, don't worry, we will send the PowerPoint to the Discord server for you guys to check out all the info again. Also, additionally, just 2 more announcements. So our first BattleBots meeting is going to be happening on Friday from 2 to 5. It's going to be in the IEEE lounge. They have been super helpful with us for the time being, since the Eastside studio is not open yet. But there we'll actually be like talking about like how to build it, how to like solder and CAD it, all that stuff. All right, I'm assuming everybody here is done.
Sorry, all right. Good evening, everyone. My name is Nick Sims. We've also got Rich and Matthew down here in the front row. We're from Covestro, and we came to talk to y'all at the Robotics Club. So, skip over that slide. Basically, don't buy our shares just because of what I'm saying. If you think we're an awesome company, please do, but not just because of what I'm saying. So, A lot of companies in the manufacturing industry, as I'll explain, we're a chemicals company. So a lot of places will start most meetings or group activities off with like a safety moment. So just by a show of hands, like who's not from the Houston area? Like who's from outside of Houston? Okay, a couple people. So you're in Houston now. Maybe you decide to stay here for a career. So I want to bring up, right, we're in the peak of hurricane season. We've seen the Gulf and the Atlantic kind of warming up. A lot of storms happening. So one thing to be aware of when you guys actually decide to live in Houston as like a permanent resident of the area, I guess, is just to be aware of that. When you guys eventually buy a house in a few years, that's something to be aware of. Make sure you're prepped before hurricane season. You don't want to wait until ABC News is saying the hurricane's 48 hours out, because then you'll go to HEB and the shelves will already be empty. So quick safety moment. How many of you guys have actually heard of Covestro before? No one? You two? Okay, well that's because you know. That's cheating. That's okay. I didn't expect you guys to. We've only really been called Covestro for a few years now, but we have a long and rich history in the chemical manufacturing industry. So we actually started off in the 50s as a joint venture company between Monsanto and Bayer. We were called Mobe at the time. In the kind of early 90s, we became Miles when the Bayer side bought the entire company. And then for a few years, we were Miles before we joined the Bayer family as a whole. So we were the material science division. There was also health science and crop science as well. In the mid-2010s, we decided to spin off as our own company, and we went from Bayer to Covestro. Now you're probably thinking, what the heck, how did they come up with that name? So it came from a combination of three words: collaboration, invested, and strong, which kind of described what we wanted to be and envision. So collaboration between our people and our customers, being invested in state-of-the-art technology and facilities around the world, and being strong in innovation, workforce, culture, and our markets in general. So our mission statement, you'll see this on our kind of freebie giveaways a lot, which please come down and grab some. I don't want to take them back to Bay Camp. Is we want to make the world a brighter place, and we want to do that by becoming fully circular. Does anyone know what being fully circular even is? No one. Okay, well, so fully circular is basically taking a product, right? So think about your mattress, right? As I'll show, we make some of the polyurethanes that go into like Tempur-Pedic mattresses. Now that mattress has a certain lifespan, maybe 10, 15 years. At the end of that lifespan, you're going to throw it away, and it goes into a dump. Being fully circular is taking that mattress and figuring out how can we take it back down to its raw ingredients or face level, and then reuse that in a process or a different process to make something else out of it. Similar is those kind of big water jug containers that you fill up your water with the little hot and cold taps, right? Those are made out of our Covestro polycarbonate, that kind of hard, rigid plastic stuff. We can actually grind those back down and feed them back into our process and reprocess that polycarbonate material. So that's what being fully circular is. And then our three values, you'll see us call those our 3 C's, being curious, courageous, and colorful. All right, so a little bit about us as an actual company. We're a very worldwide company. We have about 18,000 employees globally. We've got about 50 production sites all around the world, which I'll talk about in a little bit. Last year we did about 18 billion euros in sales. Like I said, we focus on a lot of plastic products, not the kind of polyethylene or soft plastic bag type plastic, but useful plastic like polycarbonates that I'll showcase some of those, and polyurethanes, and a lot of coatings and adhesive products that you use in everyday life. In fact, our previous CEO, I think, used to say that you're probably no more than about 3 to 5 feet away from something that contains a Covestro product. In fact, the seats that you guys are sitting on is probably some of our polyurethane material. Like I said, we strive to make plastics that are basically essential to modern day life. There's a big stigma around plastics, and I think that is very true. We need to be more cognizant of how we use plastics, especially single-use plastics, but we try and make useful things that contribute to the world and make everyone's lives better and make the world a brighter place. So our business is kind of split into two different divisions. You got the performance material side, where it's kind of a commodity business. We just want to make as much basic product as we can and just ship it out the door. as fast as we can. Then our solutions and specialty side on the other side is more of that special application, kind of tailor-made to a very specific solution for customers that we get a little bit of a higher margin, but much less volume, so we're not producing as much. So this is an example of some of our products. So the polyurethanes are split into like a rigid foam and a soft squishy foam. I've got some better examples on the next slides. Polycarbonates, which is kind of a really tough, rigid plastic, and then our coatings division as well. And then this slide kind of just shows kind of where our products go into different sectors. So you can see we're kind of spread out all throughout different industries, right? Automotive, construction, furniture, electronics, basic chemicals as well, and then a whole bunch of sports, cosmetics, health care, all that kind of stuff. So some examples of our polyurethane products. The insulation inside your refrigerator door or modern refrigerator doors is made of our MDI material. Like I said, soft squishy mattresses. Probably not what you guys have in the dorms here. Is our TDI product. If you're wearing any kind of like sneakers, like Nike sneakers, the soles in those are soft foam. Housing, insulation, that kind of spray foam stuff is our MDI. The wind turbines, most of your car dashboard is probably made out of MDI as well. And then we like to brag that the soccer ball for the Brazil World Cup, I think?
2006.
Oh, 2006, okay. The World Cup ball was actually made from a combination of our polyurethanes and our coating materials to help it be more spherical and waterproof, so when the players kick it, it kind of flies through the air better, I guess. And then, where is it? Okay. Some of our polycarbonate materials, right? We all remember these from COVID, those big sheets at the HEB store. In you guys' video of the battle bots, the box that they were, I guess, battling in was probably polycarbonate material, right? Your iPhone camera has exactly 2 of these little polycarbonate pellets. The CDs, the water jugs. I really like to talk about these little kidney dialysis contraptions. They come out looking purple because of how we make the pellets. And what's really interesting is when the hospital or dialysis center then puts that device into the autoclave to sterilize it, it turns clear, turns invisible. That's how they know that it's sterile and safe to use. So it's kind of like a magic trick, and I really like that. And then some of our coatings products, any kind of new shiny vehicle, luxury vehicle you guys have, nice clear shine coat on it. Probably one of our clear coat products, fire protection, corrosion resistance, kind of that vinyl flooring that I'm standing on right now. If anyone's wearing like waterproof anti-clumpy mascara, you're welcome. That's something that we make, or the additive that we make goes into that mascara. So in terms of our presence, in North America we have a whole bunch of sites. Our biggest manufacturing site is in Baytown, Texas. We've got a small Channelview site where Aaron's mom works. She's the site manager. So she used to be at our Baytown facility, and then she went over to Channelview. And then we've got a whole lot of smaller sites up throughout the Northeast and down in Georgia. Our main headquarters for North America is up in Pittsburgh, Pennsylvania. And then, like I said, globally we have about 50 production sites worldwide. So we've got a big presence in Europe, particularly Belgium and Germany. We've got a site in Spain as well, I believe. And then over in China, we've got our biggest manufacturing site globally in Kaohsiung, and then some sites in Thailand as well. So we're a very global company. And then in terms of our industrial park, particularly in Baytown, we've got a very, very big site. We've only developed about 30% of it, or 35%. On an average day, we have about 1,000 employees, a whole lot of contractors that help do the maintenance work and all the other things that we need to do. Like I said, we've got a rich history in Baytown. We started about 52 years ago. 52 years ago, we just recently had our big celebration for the 50th anniversary, and we're hoping to keep expanding in the years to come. So I won't go into this. This was from a different recruiting presentation that I had, but my role specifically, I'm a reliability engineer. So I deal with the day-to-day health of our mechanical equipment, so the pumps and heat exchangers. And I know you guys, as a robotics club, probably don't care about any of that. But what I wanted to highlight here was, I look at a lot of like key performance indicators, and that's something that Rich and I were actually just talking about before I got up. So Rich's group and Matthew and the digitalization team at Baytown work very heavily on giving us the tools that we need as unit engineers to do our job the best. And maybe that's something that you guys might be interested in, and Matthew's going to talk about that in a little bit. Oh, I should have taken that off. This is not advice for sophomore chemical engineers. This is just advice from me to university students. So from an academic standpoint, you guys should definitely work in teams. Obviously, this is a great organization to be a part of. You guys will get to work on not just school projects, but other projects as a group, and kind of hone in on those kind of soft skills that will make you a more well-rounded person in general. This is not something that I necessarily always did, but get started on your stuff early. You always think you have time, you don't. You can never be over-prepared for an exam, so I definitely recommend getting started as early as you possibly can. Go to office hours. Obviously, I'm not from UH, I actually went to Texas A&M, but I'm sure that your professors and TAs were just like mine. They actually genuinely care about you guys and your success, so make use of that resource as well. Next one, you've kind of already checked half the box, right? Get involved with at least one professional organization and one kind of social organization. Sounds like this is kind of a mix of both, but you should have something more professional to kind of keep you grounded in whether you guys are an electrical or mechanical engineer or even something else, right? You don't have to be an engineer to be in a robotics club, but something to keep you grounded in the major that you're focusing in, to make sure that it's actually something you want to do, right? Maybe you get to your sophomore year and realize, hey, this isn't for me. It's better to find that out now than after you graduate and you have no idea what you're doing. And then the social org, you want to have fun. So for me at A&M, it was being involved on the race team. So I was actually the driver for the Formula SAE team. So I went up to Nebraska every year and competed in a little race car against UH, actually. And then the last one, there will be a lot of stressful times. I don't know, how many of you guys are like freshmen, sophomores, juniors, seniors? Okay, so the seniors, you guys already know this. There's going to be a lot of stressful times. This is college, but it will be the best time of your life. If I could go back, I would do it in a heartbeat. So make the most of it while you can. You can sleep when you graduate, I promise. And you'll be earning money, so you'll feel better about it too. On the professional side, I don't like to say ask, there's no such thing as a dumb question, because sometimes, in my opinion, there is. But ask rookie questions, right? When you're a rookie, you're expected to ask the dumb questions, right? And you want to ask those. And then once you're a little bit more experienced, you want to ask professional or expert questions, right? You should never stop asking questions, just ask better questions, right? As you go and as you have more experience, you'll be able to hone in on that and ask expert questions. Be uncomfortable and learn new things. If you guys get to the point where you're just in a constant routine, just going in day to day, doing your thing, going home, that's probably a sign that you guys want to shake something up, do something different, change your role, get involved with something new, and keep learning, keep developing. Focus on the fundamentals. As an engineer, I have to speak to that. Sometimes when you guys get internships and jobs, you'll figure this out. Sometimes you'll want to go back to your textbook and try and do things and write a differential equation to figure out the heat transfer of a tank in a chemical plant, and you realize, well, I could have just gone outside and looked at the temperature gauge on the tank. So focus on the fundamentals. Sometimes it's a lot easier than they seem. And that kind of goes next with the next one. Go outside and see how things actually work. Perfect example is join the robotics club, right? You guys are getting real world, like hands-on experience. If you guys want to go work at NASA, this is something that's directly applicable to that. So get the real world experience that you guys need. And the last one, remember the people that helped you get to where you want to be. There were countless people that helped me to get to where I am, and I'm incredibly thankful for that. I think that's why probably all three of us are here presenting to you today, because we want to pass those lessons and advice on to you guys. And so maybe in 5 or 10 years, you guys come back and do a present to UH or Rice or wherever that might be, and you can pass on the advice that you had to someone else.
I'm just curious. What types of engineers or different types of people do you guys work with? Like electrical engineers, mechanical engineers?
How did you read my mind? So, summer internships at Covestro. So we hire chemical engineers, mechanical engineers, electrical engineers. Is there anyone that's not one of those three in the room? Oh, wow, okay, what are you? Yeah.
Oh, I'm environmental science.
Environmental science, we have a whole environmental regulatory affairs group. architecture.
Civil and construction.
I don't know. Maybe if we're building a new building or something. I don't know. Up in Pittsburgh, there's probably something to do with that.
Computer science.
Computer science. That kind of fits in directly with the digital group.
Computer science.
Computer science.
So architecture.
Architecture. Someone else with that.
Computer engineering.
Okay.
Computer science.
Okay, perfect. Yeah, so I mean, this is typically what we hire for our internships. But at a site like Baytown, where we've got, like I said, 1,000 people, there's always room for someone. There's always places and things to do. So just because we say that we're looking specifically for those engineers doesn't mean, right? We had an environmental regulatory affairs intern this summer actually. Now he happened to be an engineer, but maybe an actual environmental scientist would have been better for that. If the digital group is looking for someone to do some kind of data analysis, maybe they want to specifically target a computer scientist, right? So if we seem like a place that you guys might be interested in, definitely let us know. We will have applications opening, if they haven't already, hopefully next week before career fairs get started. During an internship at Covestro, you'll typically work on around 2 to 3 like technical projects in your unit or your kind of department area. We have a group sustainability project, which you actually get to work with other interns on a project related to sustainability at Covestro at the site. And then we have kind of weekly trainings, lunch and learns. We get you guys exposed all around the site, different departments, different groups of people, so you can see what all we have to offer. And then if you want to join us full time, we typically for the engineering students, we have kind of a manufacturing trainee program where you do kind of 2 rotations around different departments, different roles. If you're not an engineer, that might look slightly different. You might just hire directly into the position directly. But they will keep on with the mentorship and the professional development opportunities. We do like the boot camp training, so at least everyone has a fundamental understanding of how we do things. And then HR makes me put that we have competitive pay and benefits, which we do. And one thing that's not listed there is I think we really do have a great work culture. Most of us work a 980 schedule. Does anyone know what that means? No? Okay, one. That's because you're about to So a 980 schedule is where you work 5 days on week 1 and then 4 days on week 2, but you work like 9-hour days. And then if you do the math, it's some funky math, but you work your 80 hours in those 9 days, 980. Basically, it means that every second Friday you get Friday off. So like next Friday, I won't go to work, but this Friday I will, if that makes sense. Got pretty good work from home policies. I think most of the digital group is work from home.
So only from work.
50-50. So we have a lot of options, but overall I think our company culture is very good. We're not the competitive company where everyone's just competing for the next promotion or the next project or whatever it might be. I think it genuinely is a place where everyone wants to help each other succeed because that ultimately helps us all succeed. It's a very family, team-driven atmosphere, especially for young engineers. There's a lot of young employees. There's a lot of mentorship and support from those around you. Everyone's door is always open. I've never had a bad experience with anyone at Covestro. So, with that, I will pass it on to Matthew, and he's going to talk a little bit more about the digitalization group and some of the things that they work on. Yeah, just upside down. Yeah, forward back.
So, quick introduction of myself. I'm Matthew Sudesh, and I'm not a chemical engineer, not a mechanical engineer, not a computer engineer, but an electronics engineer. But most of my career I actually worked in software engineer in the manufacturing operations area. So that's kind of where I want to actually focus on manufacturing operations and technology. Right? It's not just about the field you're in, but any field can be impacted by technology. So, any of you guys heard about Industry 4.0? That's a term that's being thrown around quite a lot now. Do you know what it is? It's just all this technology improvements that have been happening in the last 5 years, whether it's AI, machine learning, robotics, drones, whatever it is. So how you actually going to implement that in an industrial environment, in a manufacturing operations? So that's what Industry 4.0 is all about, and including the data analytics and everything that will fall under that. So every company, if you look at their strategy right now, will have some amount of digitalization. they would put in there. I mean, whether it's a chemical company, whether it's oil and gas, or any type of manufacturing. Ours is a process manufacturing company. There's discrete manufacturing. You know what a discrete manufacturing is? It's basically, the automotive and, those kind of, there's assembly lines that go through stuff. That's kind of a discrete manufacturing. So ours is actually a process manufacturing. It's a continuous process with chemicals and things like that. So, but regardless, any industry, digitalization is very key moving forward in the future, because that's where you can extract a lot of value. And everybody has a strategy. Ours is called Plan Zero. So our final North Star vision is like fully autonomous plant. That doesn't mean nobody has a job there, but everything is fully automated and self-correcting and all that kind of stuff. I'll explain that in a little bit. And this is not just in operations. The life cycle of a manufacturing site is like from design, engineering, operation, and then maintenance. Like all throughout the life cycle, you will have this impact of technology, right? Somebody was talking about Fusion 360 and all those kind of stuff. Those technologies are actually used in our design phase. All the CAD related engineering design aspects of it. There's a huge amount of technology that is actually used in there. In fact, Fusion 360 is actually incorporated with AI right now, so that you get a base design already. You're actually starting from a base design, like 10 or 15 base design you can take. You just have to customize it. So the question is AI is going to take your job? No, somebody with the knowledge of AI will take your job. That's the difference. So anyway, our strategy is Plan Zero. Pretty much any manufacturing industry will have this kind of a similar strategy where digitalization and automation is very key. So how we are going to get there, right? So in our environment, what we are doing right now is we capable to do things. So a lot of these engineers and newer hires, we give them digital trainings in specific technologies and things like that. There's a lot of those technologies are coming up. So you might be a chemical engineer, or you might be an environmental engineer, but you might get trained in some machine learning, because that probably might be useful for you to apply in your specific area, right? So domain knowledge is always important. Your area of knowledge is very important, but you can achieve more if you have tools and technologies that you can apply in that area, right? So besides which stream you are, you can also actually pick up some of the other stuff like robotics and things like that. So I'm going to show some of the examples of robotics, but things that we do to improve that is actually try to teach the skills that is necessary for digitalization. Of course, the digital way of working. I know 5 or 10 years back, when you look at how we were doing operations versus now, it's basically a lot of interaction of a person that is working in the field is actually with tools, technologies and tools, not so much directly in the physical environment, because you can read data from sensors, you can control things from the control room. All kinds of technologies are available there. So get used to actually working like that. I've thrown some technologies in there. I will show that, augmented reality, virtual reality, and things like that. I'll show some of the examples later on. Of course, data is key. Data analytics skill is actually very, very key in any area you actually go. So, it doesn't matter what type of tools and technology, but at least the fundamental data part is very important for any area you actually do, because that will help you, learn a lot. And especially, you don't necessarily need to learn machine learning and AI, but at least that data analytics skills has to be there. And of course, we are implementing, these robots and drones and smart sensors, and I'll show you some of the samples. I just put some of these things here. I can just go through this. So there's a lot of routine maintenance tasks that is done by operators or contractors that go and actually read some readings or do some visual inspection and things like that. You can actually use robots, and there are in fact companies that actually do that. We're not there yet. We're trying proof of concepts and things like that. Actually, drones very much
Yeah, I was going to ask about like what are some of the things y'all do with drones. That was it.
I have one slide specifically for that.
Okay, awesome.
So drones actually, we tried spill detection and toxic gas detection. So the plant is like huge, like acres, right? If you have any kind of small leakage of gases, I mean, nobody can go walk around and find it out, unless it becomes a problem. So there is technologies available that drones will fly around the site, and the problem there is not so much the drones. From that height, how do you actually determine the air quality down there? How much precision you can get? And some of the specific chemicals that we use, the drone has to actually detect. And like she was mentioning, we have a license, because if you want to fly that kind of a drone, you need a license actually.
Yeah,
So we don't have that skill set, but we're
So, well, sorry, you have Oh. The other thing that my old unit used to do, or did, with a drone was we have a giant flare stack, right, where we're actually just basically burning off any residual waste gas that we have, so it doesn't get out of the atmosphere. We basically destroy it in a giant ball of fire. And we needed to do an inspection on this flare stack, but you can't send someone up there with it literally on fire, right? So we actually got a drone and did a flyby inspection all the way up, all the way down on 360 with a color camera and then a thermal imaging as well. So that was pretty cool for a drone use.
So again, this is very high level slide. I have to show the propaganda slides for sure. So anything in operations is actually, what's manufacturing operations all about? Safety, efficiency, and reliability, right? So it's basically, you have to have a very consistent. That's how you make money. So that's very important. And the one thing that we now focus more on is, like you mentioned, the circularity part also. So you have to have all those pillars really tight when you are actually doing a manufacturing operation, right? So I throw some technologies out there and some solutions that are focused on some of this stuff. But I guess you guys are actually interested in seeing some of the examples, right? So AR, VR. So anybody saw that device? Have you seen smart glasses? Like that's the Microsoft HoloLens, right? So there is, I think RealWear has something. Obviously, Meta has the VR device, but this is more of a mixed reality device or augmented reality. What the difference is that when you put on the glass, you can see your actual environment, but the information that you need is overlaid without obstructing your vision. So it's different than you playing a video game completely immersed. So this happened when the pandemic. During the pandemic time, not everybody can actually come to the plant and work. So only essential personnel was allowed. So they needed to communicate with all the other folks. So this was one of our options to actually do that. It's pretty cool technology, you can see, and also this can be used. You can develop software for it, where you can do actually guide people to do operations. So what that means is that you don't have to take a training of Fred. You put on this glass, and then you go out there, and what you need to do is guided by the software. Instead of go open that valve or go connect the, or check the pressure if it is this. So that was pretty cool technology that we actually did during that time. A couple of our departments are actually still using it. We're planning on developing more on that. Yeah.
So it's kind of like if I were to just kneel down here and I was wearing the VR set, right? And it's kind of like if I have an instructor behind me, correct?
You can lay it out in front of it, not behind you. Actually, it's in your field of vision. You can actually move it around if you want. I mean, this is actually, it has all the interfaces. You can talk to it. You can actually, there's a whatever overlaid in front of you, you can actually pinch and zoom and do it. I mean, it looks very weird that you are actually doing this kind of action in air, but in fact, you're actually moving a screen. So that's mixed reality. So I mean, so it's coming up big. I mean, I was in a conference last week. I mean, the technology has developed much more than this, and it is going to be used a lot of training, those kind of stuff. And there is people needed for developing content. for virtual reality and mixed reality as well.
I think the bottom left picture is a point of view from within the HoloLens, right?
This is actually a
You can
point
see
of
it.
view of the person, right? And a hand is actually showing him in a direction to do something. So let me go to the next one. IoT devices is very key technology that's happening. Those are sensors, it's everywhere, right? So anybody know what IIoT is? No? Yeah, Internet Information of Things. So what does it make, how does it become smart? Because the thing is, we had sensors before. It's not like we didn't have sensors before. All the sensors can directly connect to a cloud environment or a big, whichever environment. And they also have some smartness built into the edge where they can actually process the data that it is actually receiving and do some action there immediately. And I'm pretty sure in robotics as well, they use that. Sensors collecting the data, whether it's touch, whatever it is, and they can actually process it right there. So we use quite a bit of it, and there's a lot of transition happening with a lot of this technology in terms of smart sensors. But that was like, okay, some examples of robotics. So this is way back, like it was 4 years back. So mechanical inspection. These tanks, and like you mentioned, there are confined spaces and things that it's riskier to send people over there to do any kind of inspection. So those robots would actually go in and measure the mechanical integrity and things like that. And those are actually purpose-built robots for a specific purpose. Now the technology has gone so far, you have something very general. That's a Boston Dynamics robot, and there's actually similar ones, in other cases. There's a definition of their payload and things like that, but they are not specifically tuned for any work. You put, whatever you want it to do. You teach it to do. Before it was, whether it's vision algorithms or AI or whatever it is, you actually teach it to do. So what we were, trying to do is actually, we have some regulations in environmental where you have to actually go and read the outside, physically go and read the instruments, not just collect the data, physically go and read the instruments. So this can actually do that. You can teach it to do that. It's the vision algorithm is so better now that it can avoid obstacles and things like that. You just define the path, it will go through the path, and it will actually do, you can attach the payload, whether it's a camera or other devices which collect that data, or even a scanner, some of those things, it can actually go and do that stuff. So there's many different applications of robotics that is actually coming up in the manufacturing industry, and specifically. So there is for discrete manufacturing, it's more easier because it's an assembly line. We can choose, we can define the parameters. The process industry is a little bit more different because you have to teach it a lot because you're going into an environment with much more variations. So that's where the case of robots.
So you said it was autonomous, correct? Okay. Is there would there be any reason for to manually control it, or is it just now really good that it can just be autonomous now?
The first and foremost reason for manually controlling it is we need to get used to it. I mean, this is a chemical environment, so the last thing you want is the robot creating an accident, right? So the trust factor is one of the biggest reason, right? So this manufacturing industry is actually slow to adapt that. That's why I said the discrete manufacturing part, they got it down because they can do it in an assembly line. Because this is the autonomous part, you still have to be absolutely sure. And of course, you have to actually make some changes to the layout and path for where it goes and checks and all that kind of stuff, right? So, yeah. Any other questions? I think that's. Yeah, that's it. Aside, so.
Do you guys have any questions for us? Go ahead.
So y'all supply the different types of plastics to companies?
Yes.
Yeah.
Yeah. So we don't actually make any of those physical products that I showed. Maybe I should clarify that. We don't actually make mattresses, but we make the raw materials that we sell to someone else that makes a headlight and then gives it to Ford to put in a car, right? So.
What's y'all's management, I guess, system like, since y'all are working with so many other different companies?
Management system?
Yeah,
What
that's
do you
maybe
mean?
not the right word, but like, do you have like a specific company structure for how management is run?
Ooh.
Like a hierarchy almost? Like
Yeah,
what's our
organization,
organizational
like the
structure?
org-
The
Organization?
organizational structure is the
Yeah, we have a 4-person board, right? So it's a little smaller than it used to be when we were fair, but we're a smaller company. And after that, we just recently reorganized. We put 99% of our stuff into one organization, and then we have a lot of big commodity chemicals, right? So we call ourselves a lot of times a polymers company, but we don't make very many polymers. We make polymer precursors, all right? So when you saw the mattresses, we make TDI, but that mattress is a blend of TDI, which is an isocyanate and a polyol, right? So it's a foam. And so we make the precursors, and all that is in one division. And then we have some really specialty stuff, like when you talked about coatings. That's coatings that go on high-end cars, the real glossy stuff, and also Gorilla Glue. That's comes to the same unit.
Yeah.
That kind of thing. So, but how could I define how we're structured a little better? It's hard to answer that question quickly.
Like at our Baytown site, right? We have the 2 like production areas that are then split into units and even like subunits, and then like teams of operators and stuff. And we have like our central organizations. Like I'm in like a central reliability organization. We have a central like site management, maintenance, inspections group. We have the procurement team, the business team. So we've got like the 2 main production areas, and then all the kind of support organizations.
That's just at the manufacturing side, right? So we also have R&D in Pittsburgh. So we do a lot of R&D on our products. So it's not the kind of R&D that you might think of. We're really not inventing a lot of new products. We're inventing a lot of new uses for our products. All right, so it's a different kind of R&D, but all that happens in Pittsburgh. And then you got logistics, all the business stuff, right? And what we see is basically this plant support structure, right? You had a question?
No, you answered it. I was gonna ask, like, do you guys produce the like the chemicals?
Oh yes, yeah.
Already the internship opportunities are offered to freshman level universities.
Typically, we have not given freshmen offers purely for the reason that you guys have been in college for like 2 weeks at the time. You just don't have any like textbook knowledge physically to draw from. That being said, we have had a freshman intern in the past, or freshman intern in the past. So if you think that you're a good fit and we think that you're a great fit, it's not like we're hard no. It's just more than often than not, freshmen just don't have that kind of textbook knowledge to draw from. Like the technical expertise to really fit in well. Yeah.
So specifically for the internships, do you guys have like positions for software engineers? Like obviously.
In Baytown, normally not, right? One of them worked for Matthew a year ago.
Okay.
Yeah, it's just, not with the purpose of actually joining the company, because a lot of this internship, they go in rounds, and sometimes they actually join the company later on and those kind of stuff. But for software engineers, that probably might not be an option in Baytown. In Pittsburgh, different story. But we encourage, and what we gave them is actually good projects to work on during their internship time.
So like those would be like more remote positions, kind of.
So internship programs, the thing is that it's not just about the job and the project, because you have other collaborative activities that the company would actually arrange, and we can actually talk about. There is some competitions, there is some collaborations with other interns and those kind of stuff that happens in the internship programs actually.
I would say I don't think we've had an intern that was remote. It kind of defeats the purpose.
Yeah, no. If you're gonna be an intern for 12 weeks, I mean, we want to have you on site.
Yeah, it's not the technical skills that are developing. It's also the other side of the soft skills and dealing with other aspects of people. Aspect of it also you have developed. So that's the reason why And the internships are mostly, you want to have face-to-face, you want the interaction, you want to learn how to work in a corporate environment, those kind of stuff is more, learned when you are there.
I think what Matthew hinted on too is that we've started to use our intern program as kind of a feeder program. We like to get most of our new hires from our intern program. That wasn't always the case. We always had a lot of good interns and we had a lot of stuff for them to do, but it was kind of random, and now we're a little more organized. So what was kind of remote about the software engineer that he had is that she was at our plant, but she was really, if she was ever going to get a job, she was going to be in Pittsburgh, right? So it was a remote supervisor.
David has a question.
Oh, sorry.
So I'm in the ESO right now, and I'm actually quite interested in the internship. So if I wanted to apply, where should I go?
So one thing that we can do is I can get Aaron whenever I don't think they've posted it yet, but when they post the application, I can send it to Aaron. He can blast it out to all of you guys on your Discord server, I think you
I'll
said?
send it out on once we get the intern page, I will send it out on announcements on the Discord server.
Yep.
Which if y'all need to join the Discord server, I'll put up the presentation with the link later.
The other thing is, I don't know exactly which date. I don't think it's next week. I think it's the week after you guys have Career Fair, right?
Career Fair is on September the 13th, I believe, correct?
That day. So Covestro will have a booth at y'all's Career Fair. So if you haven't heard about an application link or anything by then, you can also just stop by the booth. I don't think any of us will be there specifically, but there will be some other representatives and hiring managers that will be there to talk to you as well. That can talk more about like your specific major, where you might fit in, some opportunities that we might have.
September 13th is 2 weeks from today.
There you go.
I just had another question about the actual company. How do you guys manage all the different contractors since you guys work with so many?
That's a tough question.
A lot of people.
We don't. Contracts. We manage it through contracts actually. So there is, yeah. So
Do you have like other people doing that specifically?
Yes.
Of contractors?
Yeah. So when you upfront contracts, so a lot of this is bulk contracts. You would actually define in the, you cannot manage everybody every time. You cannot micromanage that. So you actually have specific, pricing on certain contracts and things like that. So that's how you can manage it. I mean, yeah, of course there's, leads and, stuff. They actually look at the work. But yeah.
Your question was about contractors, like physical people, or contracts?
Just the difference. Yeah, I just wanted to know how you guys manage the quantity of different contractors for like contractors.
Contractors, yeah, that's, so you have like a support, there's people doing that, but every manager, a lot of managers have contractors, like I have several. You know what I mean, and we have a lot of different types of contractors. We have nested contractors, so the people that you can't tell the difference almost between Covestro and them. Some of our contractors have been there for 30 years, and they just like the lifestyle. You can't convince them to join Covestro, but they'll never leave, right? We have like people who aren't nested, so like they'll come in to do certain jobs, right, from a certain company, like when we clean electrical distribution equipment, right? So our big high voltage power stuff, they'll come in and do things like that. It's always contractors. They'll come in from external and do that. We have like a contractor on site who basically provides the people who are really nested, the ones that never leave, and we bring them in through there. Belcan is the company we use right now. So we've had a little different view on contractors. Yeah, that's why we've had some for a long time, especially in engineering.
Will Covestro be at both days of the career fair?
Check the email.
I think they were last year. I went to the career fair last year. I think they were there both days. Although I was only able to go to one, so.
Any other questions in the meantime while I'm figuring that out?
Go ahead.
Would you be able to compare this chemical plant to, like, say, others, like maybe in Deer Park, about Browner Road or Lloyd Road?
Ooh. Oh boy.
Like, I'm just saying, like, would you say it's?
We don't want to put that out in public, but no. I can tell you what we've seen, and it's maybe some of the general comments, right? You can probably find these on Glassdoor, that kind of thing. Our plant tends to be pretty clean. I'd say it's pretty safe. That's what you hear a lot of people out of ex-employees who have come from other plants or go to other plants, and we talk to them again. Our plant's really clean, it's really safe, it's well run. Probably a little more laid back, but safety is really important. So, you know, I mean, chemical plant life is all a little bit the same. You know what I mean? You got to make money, you got to produce. It's a company. You know, I mean, there's different ways to approach it. So, does that answer your question a little bit? Yep. And we have a lot of big continuous units. If that means something to you guys, you know what that means. So, you know, we call it, we're in a commodities business, so you only make money if you have world-class units, right, that can make the certain commodity cheaper than everybody else. So a lot of our stuff is pretty big.
Do you guys have any like interesting stories or anything, any interesting challenges y'all like experienced at Covestro?
Oh. There's no shortage of interesting challenges, right? I mean, you know, I think if your interests or have anything remotely to do with a chemical company, and you know, a lot of my career, I've been there for 35 years, so a lot of my career was part of Bayer. And I mean, I can only tell you from my experience, I got to do pretty much whatever I wanted to do. I found a way to do it. So I did a lot of stuff, you know, in my career that was a first that was going on in our company and sometimes in industry. And we're using steady state simulation, which is in my time when I got out of school when I was you guys' age, it was brand new. We did training simulators, you know, that kind of thing. And now I'm running digitalization. So there's all kinds of stuff you can do. But I mean, if you want to do research, you know what I mean? Like I said, it's mostly application research, but it's different. There's a lot of, I'd say there's a lot of things you can, but it's so varied, right? But nobody gets in your way. There's a lot of opportunities to do that. I can't give you any more specific examples except for mine. Now, Nick just got there. He can maybe tell you what he sees for himself.
I mean, I think for me, the interesting challenges, right, are the ones that something's happening and you have no idea what the answer is. And everyone's just putting your head together and trying to figure out what's happening. So something that my unit is dealing with right now is we have a whole bunch of heat exchangers, which basically take cold stuff and make it hot, take the hot stuff and make it cold, right? Just changing the temperatures of the two things. And for some reason, we're kind of basically plugging up the inside of the tubes. And so we're not able to flow as much through it, and we're not sure why. All of a sudden, on May 1st, we started plugging these things up, and we saw the efficiency decreasing. And every so often, we have to go flush it out, restart, and it comes back down, and we flush it again. So we're kind of just wrapping our heads around and going through the engineering process, right? Starting with the fundamentals and figuring out, okay, can we take samples and figure out what it is? Can we take an analysis of the acid and figure out is there something weird in the acid that's falling out of solution and plugging these exchanges up? And so those to me are the exciting ones where it's kind of just random. You don't really know, and then when eventually you do figure it out, it's kind of a really good feeling. So.
I can give you a little better answer than the one I gave you to. So Nick made me think. So one of the coolest things you can do in our industry is really design a new unit and or start it up. And that's a really unique experience. It takes years, right? So you're in this project team for years. You're building something, you don't see it for years, and then it starts construction, and then you get a lot of pressure, and you start it up, and it runs. It's a great experience.
What else?
All right, you guys are done, right?
Yeah. Yes, sir.
All right, I think that wraps it up. All right, thank you, Covestro, for dropping by talk and giving us a talk.
Thank you.
Before that, if I can take a picture of like a group